All right, so these are notes for section 7.6. And it's called coordinates in space. It's basically a three-dimensional graph. You're still going to have your x-axis, which you can see right along here. You can see your y-axis is still going up. It's still a 90-degree angle for your x and your y-axis. And then you also have a z-axis that comes out. So you're going to have an x, a y, and a z-axis. So we're talking about like three-dimensional objects, like a prism, cylinders, things like that. We're actually going to, in a chapter, I think it's unit 10, we're going to be finding out about surface areas, volumes, how much wrapping paper you would need to like wrap this, box, or how much water you would need to fill it up for volume. So that's what we're going to talk about as far as those things. But in this section, it's just talking about the coordinates, the three-dimensional coordinates. So our origin right here is the 0, 0, 0 point. So you've got over 0, up 0, and over again 0. So you're always going to go alphabetical order. You're always going to go x, then y, then z. On this graph, you can see that x comes out towards the right side, z goes to the left side, and y is always up and down, vertical. So let's look at the point right above the origin. I'm going to give you a hint. It's 3 units up. So we have 3 coordinates. So we need an x, a y, and a z. So I'm going to go over 0 on the x-axis, right? I'm going to go up 3 on the y-axis, and I'm going to go over 0 on the z-axis. So you should be looking at 0, 3, 0 there. So you go over 0, you go up 3, and then you don't go left at all. So that's going to be 0, 3, 0. What about this point over next to the x-axis? Think about that. You're going to go, it's going to be 7 units. So you're going to go over 7 units. Do I go up at all? No. So I go over 7. I don't go up, and I don't go left. So what's that going to be right here? 7, 0, 0. You went over 7, you went up 0, and you went over 0. Let's go to the one right above that. So I've got 0, 0, 0 here. I go over 7, and I go up 3, and then I stop. So I go over 7, up 3, and then over 0. So I'm thinking 7, 3, 0 would be that point there. 7 on the x-axis, 3 on the y-axis, 0 on the z-axis. What about this point right next to z over here? Right next to z. How much do I go on the x-axis? 0. How much do I go on the y-axis? 0. How much do I go on the z-axis? That would be 7. Just 7, yeah. 0, 0, 7. So if you like James Bond, that's 007 right there. All right, so there is that point. Now, what right above it, though? How would I get there? Think about that one. Do I come out here to 7 and then go up 3 and then 0? No, I don't.
You go on the x-axis.
I go x-axis, but how much do I go on the x-axis?
Nothing.
None. Then I got to go up 3 on the y-axis and out 7 on the z-axis.
Whoa.
So it's 0, 3, and then 7. So 0, 3, 7 would be that point right there. 0 on the x-axis, 3 up on the y-axis, 7 comes out on the z-axis. Bottom one out here. Okay, so you're going to start at the origin. You're going to go 7 on the x. You're not going up at all, are you?
No.
And then you're coming out on the z, 7. So yeah, 707 right there. 707. And how do I get to that last final point?
737.
No, this is a positive amount coming out to the right here. This is a positive up. Or this is nothing up, and then you got a positive coming out here. Negatives would be back the other direction. So those aren't negative. These are positive. It's in the positive plane, so it is positive. This last one would be 737. You're going to go over 7, up 3, and out 7. So that would be 737. Let's look at the next prism. It's a rectangular prism on the next one. This is also a rectangular prism. Here's another rectangular prism. You can see a little bit more accurate on your X and Y axis, because usually the Y straight up and down and X is to the right. Z would come out at another right angle, would come straight out. And this is called, this paper that I'm using, this dot paper, it's called isometric dot paper. So on the last one and on this one, it just helps you draw in objects that make it look three-dimensional. So let's see, the first one they want to find is point C right here. So C is up here. How do I get from the origin to point C? How far do I go over, up, and over, or whatever for my point? So I'm going to start it here. I'm going to need to go over how many? 15. And because that's 15 right here. And I go up how many? That's an 8 right there for the Y. It's up 8. So over 15, up 8, and 0. That's it. You stop there. So 15, 8, 0 is C. E is the next point they want. So E is down here next to the Z. So you're going to go straight out to this point E right here. That means you didn't do any X. You didn't do any Y. You just went straight out how many? 5. So what would it be? 0, 0, and 5. Yep. That's the 005 agent. Yeah. F. To get to F, you didn't go over at all on the x-axis, did you?
No.
You went up 8 on the y-axis and out 5 on the z-axis. So it's just 0, and then 8, and then 5. 0, 8, 5 there for point F. That's how you would get to F. You go over 0, up 8, and out 5 on the z-axis. G is the farthest point away from the A, the origin. How would I get to that point? I need 3 moves. I gotta go 15 out, I gotta go 8 up, and I gotta go 5 out. So yeah, 15, 8, and 5 would be your point for point G. Now, do you think I could attach a string to point A and attach the same string to point G and find out how long that string is? Because that would be like from the bottom corner of the box to the upper corner on the other side of the box, right? So you'd see a string in there. Could we find that distance?
Yeah.
Yeah, we could use the distance formula. Almost the same as what we had when we had two coordinates in each point. Here's the new distance formula for three-dimensional. What's different about it? You just added the z's. These are the same. This right here, the x2 minus x1 squared is the same. The y2 minus y1 is the same. This is what we added in. Because you have a third coordinate. So you have a third axis. So you see this on the board, it's a purple dotted line right here. Okay, that's from one corner of the box to the other top corner of the box. We could find that distance simply by plugging in our distance formula. So here's the way I would set it up. I would put my big square root. This first parentheses has x2 minus x1. x2 minus x1. I counted the c as my x2 since it was the farthest over here. So I did x2, 6, minus x1, 0. I did 6 minus 0, and that's what I put right in here. And then I had 3 was my y2 number. 0 was my y1 number. So I did 3 minus 0 right here. And then 0 here was my z2. And then 5 was my z1. So I did 0 minus 5 and got my third point, third parenthesis. And now you just simplify. You can do a lot of that stuff in your head. So you're going to get 6 squared, which is 36. 3 squared, which is 9. Negative 5 squared is still a positive 25. Negative times a negative comes out as a positive. So that would still be a positive 25. When you add these together, you get the square root of 70, which is approximately 8.37 units, or you could say 8.4 units if you want to round it off. 8.4 units. So that's the distance formula in space as far as the 3 dimensions. You just plug in the distance formula that will get you how far it is. Now this is units on your graph. 8.37 or 8.4. All right, the last one on there talks about 2 airplanes. I forgot to tell you where the airport was. So it says 2 airplanes are located at those 2 points. And it says which airplane is located farther from the airport. The airport is the origin, 0, 0, 0. That's the airport. So they want to know which plane is farther away from the airport and how much farther that would be. So we need to find plane A to the airport. And we need to find out plane B to the airport. So we need to use our distance formula that we just used and find out how far each plane is from the airport. Now I would use the airplanes as my x2 or y2 and z2 point. The origin, I'd use the 0, 0, 0 as the x1, y1, and z1. So I would start with 5 minus 0. That just keeps everything positive. 5 minus 0 squared, 6 minus 0 squared, and z2 minus z1 would be 2 minus 0 squared. So you're going to end up with 5 squared, which is 25, plus 6 squared, which is 36, plus 2 squared, which is 4. 25 plus 36 plus 4 is 65. So square root of 65. Square root of 65 is 1 more than the square root of 64. So the square root of 64 is 8. So the square root of 65 is probably 8.1. Probably was about 8.08 or something, but we'll round it to 8.1. Oh, okay. 8.06, so it rounds up to 8.1. From point B or airplane B to the airport. These are big square roots. I'm going to do the same thing. The plane is going to be the second point, airport the first point, so negative 4 minus 0 squared, 3 minus 0 squared, and negative 5 minus 0 squared. So we just did x2 minus x1, y2 minus y1, z2 minus z1, squared them. Negative 4 squared is still positive 16. Oops. 3 squared is 9. And negative 5 squared is still a positive 25. So let's see. 16 and 9 is 25 plus another 25. Radical 50. And that's 1 more than radical 49. Radical 49 is 7, so it's probably 7.1, yeah. So which airplane is farther from the airport? A. A is farther. A is farther by how much? 1 unit. 1 unit. Now we don't know what that unit might be. On this graph, each unit might be 100 miles because it's an airplane. So it could be 100 miles, could be 1,000 miles, it could be 500 miles. You just don't know on this unit. But on the graph, they're 1 unit farther away. So that's the distance formula for 3-dimensional space. Told you they were pretty quick notes today. That was it. That's all I got.